Integration by parts is your safety net. Almost any integral can be done with integration by parts. A lot of them would be extremely difficult that way, but it's a method that, when in doubt, you can probably use it. So this is the formula for integration by parts. This half is the integral you're given for the problem. So you have the integral of u dv equals uv minus the integral of v du. Now, this is one of those things you just have to remember, and we'll do an example. It'll make more sense. I feel like I say this every video, like memorize it. I know you're confused now, that's why you're watching the fucking video. And let's do one. So let's say we have the integral of x squared times ln x dx. Now, u substitution is not gonna work here. There are no rules we know for this. We're gonna have to use integration by parts. So, like I said, in the formula here, you have the integral of u dv. Now, in the problem you're given, you can decide which one is u and which one is dv. So remember that. You can make whatever you want your u and your dv. You can even make dx dv if that were to help you out. There's no restriction, so let's see what's gonna work best for this problem. So when you're deciding what your u and your dv is gonna be, you are planning what's gonna fit into the second half of this formula. So as you can see, this formula has way more than just u and dv. It has v and it has du, which means you're gonna be taking the derivative of the u you pick and the integral of the dv you pick. So looking at this problem, taking the integral of ln x is far more difficult than taking the derivative of it. We know the derivative of ln x is 1 over x. So I'm gonna say our u is equal to ln x, which must make our dv equal to x squared. So now we take the derivative of our u to get our du for this part of the formula. So the derivative of ln x du equals 1 over x. Well, let's go over here to our dv. We're going to take the integral of our dv to find the v that goes in here. So the integral of x squared is x cubed over 3, just using the power rule. Let's just plug in everything we found out into our integration by parts formula. So u, ln x, v, we just found v, times, so I'm going to put it like this, x cubed over 3, minus the integral of v, we just found v, x cubed over 3, times du. Our du is 1 over x. 1 over x. Now we have an integral even your dumbass could evaluate. So, look, Josh, what cancels here?
The x.
Yes, one of these x's. So, if we rewrite what we have, we canceled one of these x's here, and we're left with x squared. And I'm gonna kind of skip a step here. We can pull out this 1/3. So we have 1/3 times the integral of x squared. Now we know what the integral of x squared is, so let's rewrite what we have again. So the integral of x squared is x cubed over 3. And our final answer is going to be ln x times x cubed over 3. And remember, when we multiply this in, this is going to be x cubed over 9. So you could factor out the 1/3, you could factor out the x cubed if you want, simplify your answer, but that's how you do integration by parts. So the most important part of these problems, pick the correct u and the correct dv. Let's look what would have happened if we would have flipped it. So if we would have said u equals x squared and dv equals ln x, I can tell you that the integral of ln x is x ln x minus x, and then du equals 2x. This sucks. This sucks so much. What the fuck are we supposed to do with this? Look, like you plug in, you would get x squared, x ln x minus the integral of x ln x minus x times du times 2x. That made it even more difficult. So make sure you're picking the right u and dv. Think about it before you pick them. Think about what's gonna make the problem easier to evaluate. Let's do a harder one, bro. That was a fucking pussy ass problem.
So, are you always finding the derivative of u and the integral of dv?
Yeah. So you are,
like, how do you know?
You know because you need to find all the information for this formula. So this is the integral you're given, and this is what you're trying to plug into. But if you're only given u and dv, you don't have v and you don't have du.
Okay.
So you know when you pick your u, you have to find your du and vice versa. You're given your dv, but you have to solve for v.
So when you solve for v, that means integration?
Yes.
Okay, I didn't learn that yet.
All right, so let's do more math. So a lot of intuition with calculus problems comes from practice. I know your first thought may have been to look at this and go, oh, okay, well, we'll just split this up into the integral of secant x times secant squared x, and then, you know, the integral of secant x times 1 plus tan squared x, and then, you know, multiply it out. Which is gonna take you a lot longer to do it that way. I think using integration by parts here is gonna be quicker, because notice that when you get to this step and you split these up, like I said, there are no bounds on what your u and your dv are. So if you make this your dv, you know that the integral of secant squared x is tan x. So that's one way to look at these problems. You're saying, what's gonna make this a more manageable integral? So I'm gonna start this over, and we're gonna use integration by parts. So we split this up, and we know that the integral of secant squared x is tangent x. So we're gonna make our u value secant x, because we're gonna be deriving our u value and integrating our dv value, and we know we wanna integrate this one. So we're gonna say u equals secant x, and dv equals secant squared x. So the derivative of secant x du equals secant x tan x. And the integral of our dv is just going to be tan x. So let's just plug in our u, secant x, our v, tan x, minus the integral of v tan times du secant tan. I forgot this little x. And dude, dx. Didn't forget. All right, so we're gonna multiply this out. So this is really, I'm just rewriting this information here. The integral, so tan times tan is tan squared. So we have secant x tan squared x dx. So I chose this problem for a reason. Sometimes it's gonna look like, oh, I gotta do integration by parts again. I think this is a really important problem to know how to do in C. So follow me, and the intuition will come as you do more of these. We know that tan squared x is secant squared x minus 1. So let's rewrite this integral here.
No
All right.
dx?
Oh shit. dx, fuck, I hate dx. Josh, do you see this bullshit? You did all this work only to get the same integral as the original problem. What the fuck? That's awesome. That's a really good thing. If you ever see that, you probably did something right, and I'll show you why. So as we know, this minus sign here is going to allow us to evaluate these as separate integrals. So we could rewrite this as... Actually, I think that's wrong. Yeah. This...
Why?
This this negative has to get distributed to this. Really, this is plus here. Like I said, it's dope that we got this. It's fucking dope. So if we say all of this, it's really simple. It's just people don't think of this. If we say all of this is equal to the integral of, what a shitty fucking integral that was, cube x dx. I can't even bear to look at this bullshit. Because really, that's what we're doing, right? This is all equal to the integral of this. We're just trying to find the integral of this. So what we're gonna do is just basic algebra. We're just gonna add this to both sides. So plus integral secant cube x plus integral secant cube x. This will cancel from this side. and we'll get secant x tan x plus integral of secant x equals 2 secant cubed x dx. Now it's game over because one of our integral rules, we already know what the integral of secant x is, so we can rewrite this. Plus, so the integral of secant x is ln secant x plus tan x. And now that all equals 2 times the integral of secant cubed x dx. Well, take a crazy guess, divide by 2, and that's your answer. So really, when we found this same integral negated from the original problem, we could just add it to the other side and the problem actually became very simple. So this is going to be your final answer. Fuck mother fucking piece of fuck. Plus C. Dude,
No!
I'm not.
You would have got the whole thing wrong.
Yo, they probably think I'm playing around in these videos when I forget the plus C. It is no joke.
Bro,
I am a garbage
dude,
fucking tutor.
We all forget the plus C.
That means a lot that you would say that to me at a time like this, dude. Thank you so much. Thanks for watching this video. If you liked it, make sure to roll up a fucking fat one, smoke it with your mom. And shout out my boy Matt Ox. Shout out Migo, shout out Zato. Subscribe. Shout out my math BFF girl. I miss you. I never met you, but I miss you. And alright.